All right, so everybody, this is the limit. All right, we look here. We should try to put 0 in, right? Direct substitution always, always. Yay, 0. But wait a minute, undefined. All right, pretty key here that it's a sign. So again, without being told, just writing 0, great guess. I'm pretty sure the limit of this is 0, but you got to prove it too. Okay, so it helps if I don't have this froze. Let me unfreeze it. So we're going to go -1. And everyone, this is undeniable. We start with the fact that we know is undeniable, right? The range of sign is always -1 to 1. It's an absolute guarantee. But we have not yet squeezed the function in the limit. But the only difference after you do this is the x to the 6. So we just multiply all the things by x to the 6th. All right, everybody, squeeze theorem states if you can squeeze a function between two functions and you show the limit of the outside two is the same around your value of a, so around 0, then the limit in between is the same. So the next step I do is I want to, and I can tell by looking at it, but I want to make sure that the limit of -x to the 6 at 0 equals the limit at x to the 6 at 0, which are both 0. Boom. It is time to say we know what this is. So, by squeeze, right, by squeeze, since the function is sandwiched or squeezed between, whoops, I gotta get the x to the 6 there, the two known functions, and we show that the limits as you approach 0 of the two functions are equal to a same value. It doesn't have to be 0, right? But it is a lot, right? It doesn't have to be, but it is a lot. Then the limit of the squeeze function, which this time is what we asked, is equal to that, which this time is 0. So this equals 0. All right? And we just proved it by squeeze. We just proved it by squeeze. All right? Again, I just check, and again, you might get to college, everybody, and they might tell you to do it a certain order. Then do it a certain order. But what I'm looking for is squeeze. You show it was squeezed, you showed the limits were 0, and you made the statement that the limit in between is that value. There are 4 things to show, right, every time. But you have to name squeeze by squeeze. Okay, you got to name squeeze by squeeze. All right, everybody, we should be able to state the squeeze theorem. This seems like a good place on the video to show the squeeze theorem. So everybody, and this is just right from your textbook, right? If f of x is less than or equal to g of x is less than h of x, if the g of x is squeezed and the limits at a are the same L, then the limit of g of x is also L, and it gives this picture, right? Everybody, this is squeeze theorem. You should be able to state it, all right? Because if you can't state it, it's hard to use it. Do you guys agree? If you can't really state it, pretty hard to use. So all you gotta say is, I squeeze a function between two. Do I care if it's f, g, and h, or g, f, and h? No, I don't care, guys. It doesn't have to be the book, right? But you squeeze it, you check the outside limits, then you know the one in the middle is the same as the other two. All right? Boom. Doesn't have to be 0. Guys, in fact, out of the textbook I stole this picture from, it has the limit off of 0. If you're on the AP test and you're not sure what to do, what should you guess? 0. If you get lost, guess 0 or 1 almost always, all right? All right, let's pause that one. Can you stop that and we'll start a new one?